Okay, so now that we know how to come up with a matrix inverse and we know what the identity matrix is, we can talk about solving a matrix equation. Suppose AX equals B. Let's suppose that we have, I don't know, 3x equals 15. Could be any little equation like that. How do you solve for x? Well, you solve for x by getting rid of the 3. To get rid of the 3, you basically turn it into a 1 by either dividing by 3, which is doing the inverse of multiplication, or multiplying by 1/3. Also the inverse. The multiplicative inverse of 3 is 1/3. And so multiplying both sides by 1/3 gives me a 1 here. So really what we're doing is we're turning that into a 1 by multiplying by its inverse. Okay, so that's what we're going to do for matrices also. We can't divide with matrices. There's no such thing as matrix division. So we can't divide both sides by 3 like we would, we can't do it like that. So we multiply by an inverse the same way we're doing here. Okay, so let's say you have originally this equation, and it's a matrix equation. A is a matrix, X is a matrix, B is a matrix. So matrix A times matrix X equals matrix B, but we're trying to find matrix X. We don't know it. Okay, so to get rid of matrix A, to get it away from matrix X, because always when you're solving, it means isolating what you're looking for. So we're looking for X, we have to isolate it. We have to get A away from it. So I have to multiply by the inverse matrix, because together these two will make the matrix equivalent of 1, which is the identity matrix. And anything you do to one side, you have to do the other side. So on the left here, these two become I. This still says A inverse times B. And I times X, remember any matrix times the identity matrix, or the identity matrix times any matrix, just gives me that original matrix. So I times X is just X, is what I'm saying. One thing to notice here, since I had to multiply by A inverse on the left-hand side to get rid of it over here, I have to multiply on the left-hand side over here as well. Remember, matrix, matrix multiplication is not commutative, so the order matters. So since we're multiplying by A inverse on the left here, we need to do on the left here, so you kind of squeeze it in to the equation. All right, so that's the idea. That's the whole reason we needed to know what an inverse matrix was, how to find it, and what the identity matrix was, is so that we could do this. All right, so for instance, and we don't need the solution yet. Pretend you didn't see it. There you go. For instance, so this would be my matrix A. This would be my matrix B. And this is really a common thing we do, is we refer to it by those particular 3 letters, AX equals B. So I need to find the inverse to matrix A so that I can multiply by it out here and right here. And then this will be the identity matrix, and the identity matrix times X is just X. So that will mean I just have an X on the left, which is the goal, getting X alone. So first of all, remember a 2 by 2 is the one type of matrix that we will be asked or are expected to be able to find the inverse of by hand. So let's look at this one. It starts out, remember this is the formula, 1 over determinant of A times, and then you swap the placement of these 2 entries and negate these 2 entries. Okay? So in other words, the 1 and the 7 are going to trade places. The 7 goes here and the 1 goes here. And the negative, or the 1 and the 6 here, both become negatives. Then I also need to have the determinant of this matrix, and it's 7, 1 times 7, minus 6, 1 times 6. So 7 minus 6 is just 1. So my inverse matrix is just 7, negative 1, negative 6, 1. Which is nice, because that's not too yucky. So that's what I'm going to do here. So I'm going to multiply both sides by that matrix. So I have 7, negative 1, negative 6, 1 times 1, 1, 6, 7. And we could go ahead and multiply this just to make sure we did it right. It should give me what? The identity matrix, right? So you can make sure that that happens. It will. And on this side, we're also going to multiply in front, which is on the left. Same matrix we multiply by on the left here, times 2, 3, 1, 4. Okay, this is going to give me I, which just gives me X on the left. This I actually need to multiply out, so I get 7 times 2, which is 14, plus negative 1 times positive 1, which is negative 1. So 14 minus 1 is 13. 7 times 3, which is 21. Negative 1 times 4 is negative 4, so 21 minus 4 is 17. Negative 6 times 2 is negative 12, plus 1 times 1 is negative 11. Negative 6 times 3 is negative 18, plus 1 times 4 is negative 14. Okay, so this should be my answer for X. And that is what we get. You can always check yourself by taking this matrix and doing this matrix A times X that we came up with and seeing if you get B. You're solving an equation, and anytime you solve an equation, whether it's a matrix equation or any other kind of equation, you could check your work by plugging it back in. Okay, so let's go ahead and look at this next one. All right. Now you notice this is not a square matrix, and you might be thinking, well, wait a minute, I thought we had to have square matrices. You have to have a square matrix to be able to find the inverse. We don't need the inverse of this. We need the inverse of this. This is my A. This is my B. I'm going to multiply on both sides by A inverse. And so this side's going to become I times X, which is just X, equals A inverse times B. So pretty much every time you solve a matrix equation, it works out the exact same way. If you consider the original equation to be A, X equals B, on both sides you're multiplying by A inverse. This basically cancels out, and you get A inverse times B. So you don't necessarily have to go through the whole process of writing it on both sides and everything every time if you know this, because it works out this way every single time, assuming that your original matrix equation is AX times B. So this is a 3 by 3. We already said we weren't going to do 3 by 3 inverses by hand, so this is where you need your graphing calculator. So in your graphing calculator, you're going to go to second matrix, and you're wanting to go over to the edit menu because you need to change that first matrix. And I'm going to change matrix A to be this one right here. So I'm going to press 1, make sure that it's set up to be a 3 by 3, and then start putting in my entries. Got 5, 0, 1, 2, negative 3. Make sure you use a negative, not the minus. 2, say 1, negative 1, and 4. Okay, now the other thing you need to make sure of is at this point, don't just start trying to do calculations because you're still in the matrix. No pun intended. Okay, so I'm going to get out of here by doing second quit. So second quit. Now, I also need my B matrix in there. So let's go ahead and put B matrix in there. Go over to edit. Put my B matrix in there. My B matrix is actually a 3 by 2. So I'm going to set it up to be a 3 by 2. Then start putting in entries. And then I'm going to leave that matrix. Okay, so we know that this is what we need to do to solve. So if you're using a calculator, it's actually really super simple. You just put in your A, put in your B, and then do this. This happens on the home screen. So on the home screen, I'm going to go to matrix, so second matrix, and I'm just going to get the name matrix A. So I'm just going to press 1. Takes it to the home screen. Then remember I use this button to do inverse, the X to the negative 1. And then I need the matrix B name. You don't even have to press time. It understands that writing it right next to each other means times. So press 2. And my matrix, for a second there, I thought it was blank. My matrix is going to be 0, 1, 6, 2, 1, -1. Please be careful that you do not write your matrix just the same way that a graphing calculator does. Graphing calculator doesn't know better. You do. So write it like a matrix, not like that. So my answer should be 0, 1, 6, 2, 1, -1, and that's how I write it, like a real matrix with a single bracket that goes all the way up the left side and a single bracket all the way up the right side. If you put brackets on each row the way the calculator does, I will take off. Okay? You have to do the thinking. Don't try to let the calculator do the thinking. All right, so we can use this to solve a matrix, or excuse me, to solve a system of equations. We can solve a matrix equation to solve a system of equations. And basically, our A matrix is just all of the coefficients. Okay, now notice first that you want this to be in standard order. In other words, put the variables in alphabetical order in each statement and the numbers over on the right. Okay, so once you've done that, you have a coefficient matrix becomes A. So coefficients here are -3, 4, 2, and -1. It's almost just like you went up here and erased the letters. And that left-hand side of the equation with the letters erased becomes A. X is X and Y. You don't put anything in for that. That's what you're going to find. And B is the constants. This is called the constant matrix. So here's your coefficient matrix. And here's your constant matrix. Okay? Then put in A, put in B, and do A inverse times B, just like we did on the last problem. So you just put A in your calculator, it's a 2 by 2. Put B in your calculator, it's a 2 by 1. And then you will calculate A inverse B on the home screen the same way we did on the last problem. It's kind of nice because after you've done one of these, if you go back and you change A and B, like let's suppose I had changed it, I can do second enter and it brings up that same expression, A inverse times B, and I could just press enter, and if I had changed A and B, it would give me the new ones. So if this is what you're doing on a whole worksheet or a whole homework problem, you could just pretty much keep doing this in terms of typing in the actual calculations. You do have to change your matrices, of course, every time. But it's kind of nice to already have that in the home screen and be able to just reuse it. So go ahead and try this one and see if you get the right thing, which is X is -7, Y is -4. Now we do want to write these as an ordered pair, or if it were 3 variables, it's what we call an ordered triple. All right, let's see. Let's look at this one. Okay, my coefficients, it's in order. My coefficients are 7, 3, 14, -4. So here's my coefficient matrix. My variables are X and Y. That's my variable matrix. My constants are 11 and 2. That's my constant matrix. So in the calculator, I will put this in, and then I will calculate X by doing A inverse times B. So this is a really simple way to solve matrix equations. So go ahead and try that one. You should get that. One last one. This one. I'll let you go ahead and start it, but keep in mind that it has to be in standard form. All the equations have to be in standard form so that the variables align. And currently they are not. So fix that, and then you could figure out what your coefficient matrix and your constant matrix, what they both are, and put them in the calculator. And that's all there is to it. So go ahead and do that problem. So you're solving for X, Y, and Z.